Okay, what is it today? 10/8/2019. Okay, so here's our objective today. We're going to be simplifying roots, and we're also going to talk about negative exponents. Okay, simplifying roots, and we'll also have some negative exponents in there. Okay, Jay's going to put his phone away. Of course he is. Okay, example one's pretty easy. We actually looked at one like this. In fact, Caden gave the answer to the one that was up there. But if we take a look at this, we know what the square root of 9 is. 3. We know what the square root of 16 is 4. So really, in our brain, we just did this. We just did the square root of 9 over the square root of 16, right? Because we saw the 3 and the 4. So we broke it up into two different roots. So really, we got an answer of 3 over 4. Right? Thumbs up. And you guys did that in your head. You didn't break it up in your head. You already had it. Number 2, okay, again, we briefly talked about this rule. You're not supposed to have a square at the bottom. It doesn't make sense. And the reason we want to clear it is later on it'll help us divide, okay? So we fix the problem with the problem. We need to make a perfect root in the bottom. 25 is a nice number, right? If I have the square root of 25, I can do it. And that's why we fix the problem with the problem. Because if I go square root of 5, square root of 5, what I make in the denominator is I make a perfect square root, right, in the denominator. Multiply by square root of 5, square root of 5. I'm making a perfect root. Square root of 25 is 5. Boom, we've cleared the denominator. But the numerator, we don't care. The numerator can have the square root at the bottom, or on the top, I'm sorry. And so I get 3 times square root of 5. That's a regular number. That's a square root. Okay. Okay. Now, super tempting to say, let's divide the 5s, right? Now, you watching? That is not a 5. Sure it is, Bruce Davies, that's 5. That is not a 5. That is 2.24, blah, 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 blah. You can't divide the 5 into 2.24. That is not 5. Everybody got that? That is 2.24, blah, 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 blah. Okay? All right, moving on. Example 3 is just like example 2, but first we've got to make it look like example 2, because I'm going to rewrite it as the square root of 5 times the square root of 7, okay? When I do that, again, we're going to fix the problem with the problem. See, I need to make the square root of 49 down here. I need to make a square root of 49 so I can take the square root of 49, right? So I'll multiply by the square root of 7, square root of 7. That's why I say, last year I said fix the problem with the problem, but the reason is because then I make a perfect square. So I wind up with a square root of 49, and the square root of 49 is a 7, okay? 7 times 7, square root of 49. Square root of 49 is a 7. So I've cleared the denominator. The numerator is just going to be a square root of 35, okay? And again, don't divide those, because that's not really 35. That's like a 5.9 blah, 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 okay? Everybody got that? Now, 5. Okay, there's two ways to do 5. We want to rewrite it. So first of all, I am going to multiply. I'm going to write this down. I'm going to multiply exponents. Oh, I missed number 4, didn't I?
Yeah.
Oh, I got ahead of myself. My bad. Okay, example 4. Now, what I need to do, this is the tricky part, I need to make a perfect cube. So I need to make right there a perfect cube. I want to be able to take the cube root and get a good number, right? I want to take the, yep, because I like that. I want to take a cube root of a good number, and these are my perfect cubes. So I heard people say, all right, let's make it an 8. If we make it an 8, we can take the cube root of 8, can't we? So how do we make this into an 8? Multiply by 2, right? So we're going to multiply by cube root of, I'm going to go cube root of 2 over the cube root of 2. So I'll wind up with a cube root of 8, which is plain old 2. So we've cleared the denominator, right? And that's our goal, is to clear the denominator. The numerator will just multiply. We'll get the cube root of 4, which we can't do. you can't do the cube root of 4. It's a bad decimal. So we'll just leave it as the cube root of 4. And we've cleared the denominator, okay? John, do they do this when you're in France? Is this one of the rules they did in France? Yeah. It's kind of a, they do it in America. Okay, example 5. Back to example 5. I'm going to multiply exponents. So when you have something that has an exponent to an exponent, we multiply the exponents. You know that. So real quick, just watch. Don't write this down. Don't write this down. I mean, if you had x cubed, x squared cubed, what would you do? You'd make it x to the 6th, right? You just multiply exponents. You guys have seen that before, right? Because it means x squared, x squared, x squared. So we're going to do the same thing, but just with fractions. So we're going to go 2 times 1/4. Okay, 2 times 1/4 gives me a 3 to the 2/4, or 1/2. Correct. Now, a 1/2 power is a square. So on the side, if you have x to the 1/2 power, that is always the same thing as the square root of x. Okay, you need to remember that. You need to remember that. If you ever take calculus, you will use that rule all the time. So I'm just going to rewrite this as the square root of 3. 1/2 power, and there's an invisible, think about this, there's an invisible number here. What's the invisible number here? Yep, and there is a 1 right there. So it kind of makes sense. I mean, math, again, there's a lot of rules, right? But math always makes sense. Okay, number 6. Number 6 is a little weird. Well, let me put a 1 right here. Okay, I'm going to put a 1 right there. And I'm going to do a little work on the board before I do anything that you guys are going to say, oh, I get it. Hold on, I get it. If I had x to the 10th over x to the 7th, what do? Just here. You subtract exponents, don't you? So what are we going to do here? Yeah, so now what is 1/5 minus 1?
Or negative 1/5.
Yeah. So if we took and subtracted the exponents, we're going to have a 10 to the 1/5 minus 1. Or 10 to the 1/5 minus 5/5, or 10 to the negative 4/5. And I like that answer. If you want to get fancy with this, you could make it 1 over the 5th root of 10 to the 4th. But which answer do you like better? Probably that one, right?
So we could just leave it like that?
Yeah, that's a fine answer because you've done the most important step, and that was to subtract exponents, okay? How am I doing, okay? Example 7, let's do the same thing, right? Didn't we multiply exponents? Am I going too fast? Okay, let's do the same thing. Let's multiply exponents. All right, I can do that. I'm going to get a 3 over negative 1. Yes. Okay, because on the side, if I went 4, I'll do a little side work here. If I went 4 times a negative 1/4, I get a negative 4 over 4, which is negative 1. Nice job. Nice job, Caden. And then I might rewrite that as 1 over 3. Ooh. Oh. Negative exponents, 1 over, right? Remember we talked about that yesterday? To the 1 power, okay. I would take this probably on that one. You probably like that answer better, don't you? Yeah. Okay, number 8. All right, so let's try and do what's inside first, okay? So,
Would you add those exponents?
you're so smart. Ahead of me, I like that. So, if I had, Lily, if I had x squared times x cubed, you would say it again. You're going to add exponents. So I'm going to add exponents. You guys agree? Same base. Thank you, Lily. You're way ahead of me. Okay, so I'm going to add exponents. So I'm going to take my 2, and I'm going to add. What is negative 3/4 plus 1/4? Well, if I add those exponents, what do I get? Negative 2/4 or negative 1/2. Okay? So I get a 2 to the negative 1/2 to the negative 1. because I brought back in this -1, right? Multiply exponents, you guys, okay, multiply, so it's multiply exponents. So I multiply -1/2 times the -1, what do you get? 2 to the positive 1/2. And we know that's the square root. Hopefully we know that, right? We can rewrite that as the square root of 2. How am I doing?
Wouldn't you also multiply the 2 inside the parentheses with the other 2?
Okay, here,
Yeah.
here, right? Okay. Yeah, let me ask. Okay. Hold on. Good question. Okay. 3 squared times 3 to the 5th. What's the answer?
Wouldn't it be 9?
9 to the
Oh,
7th.
and I'll show you what. Great question. You ask the best questions. Watch. You know what? Watch this. You'll totally see it. Well, you ready? This is 3 times 3, right? Times 3 times 3 times 3 times 3 times 3. So I don't have any 9s, do I? I have how many 3s? So it's really 3 to the 7th. Really good question. You ask the best questions. Please keep asking the questions, because you know what I find is the kid that's brave enough to ask questions, you're asking it for everybody else. Does that make sense?
Okay.
All right. Turn the page. Thank you, Lily. Okay, we're almost there. Now, woo! All right. Cube root of 81 times cube root of 9. All right, so let's...
Slide up, Mr. Davis.
Oh, yeah, thank you. All right, so let's try this. First of all, if I rewrite this as cube root of, let's see, what's 9 times 81? Oh, that's got to be a good number, isn't it?
Yes,
That's a good number. 729. I think that's up here, isn't it?
Yep, it's right there.
Yep, so what's our answer?
9.
9. Okay, and I'm going to show you another way. If I wasn't sure, let's say I don't have a calculator and I'm not a super genius, because I'm not. Check this out. I could have rewritten these both as, you ready? Cube root of 9 squared. You okay with that?
Yeah.
Times cube root of 9, which would have made cube root of 9 to the 3rd power, right? And then you can see those cancel and you're left with 9. If you're not a super genius and didn't see that, okay? Right, but you guys were super geniuses, so, you know. Okay. 10. We did this one. Didn't we do this one in our journal?
Yep, it's 5.
Yeah. Another way to do it. You guys agree? So I can multiply those, and I end up... But another way to do that, I want to show you another way. We could do this. I could go the cube root of 5 times the cube root of 25, because I can divide those two, because they're both cube roots. I can do that. I can go the cube root of 50 divided by the cube root of 2 is the cube root of 25, right? Well, you can't divide both, right? Just divide one or the other. And I'll show you that too, okay? You're asking great questions. So I get the cube root of 125, right? Which is 5. Autumn, you asked a really good question too. I like it when you guys ask these questions, because a lot of times kids get misconceptions. So let me throw this up real quickly. Let's do a 6 times 12 times 18 divided by 3, okay? Do you divide the 3 into all 3 of these? Or do you just divide the 3 once?
Once.
Just once. Does that make sense? Just once. And I same thing on that. Just divide it once. You don't divide both, right? Unless you had a plus sign here, then you divide it all 3. Okay? Let me make it easier numbers for you. Super easy numbers, okay? Make this easier numbers, okay? Let me go 4 times 3 divided by 4. Okay, what's the answer? 3. There we agree, 3. But if you had to divide into both, and then you can prove it. So 12 divided by 4 is 3, right? So you only divide it once. Does that make sense? That's easier to see, okay? All right, almost done. All right, we're almost done. And I'll stop blabbing. Okay, this thing, whew, this thing looks really bad. But you know what? I'm going to do a couple of things to make this easier for me. Let's see here. 4th root. Let's do this right off the bat. Let's make this the 8th root of 3 squared. I'm going to do that first. Okay. How's that going to help me? Well,
3 times.
on the side, I'm going to show you a little side work. Yeah. There you go. A little side work. If I had the 8th root of 3 squared, it's the same thing as 3 to the 2/8 power. 2/8, who gets 2/8? Aiden, what'd you say? That's the same thing as a 3 to the 1/4. So becomes the 4th root. So slide it back up. This is really going to be the 4th root of 3. Oh, that's hard to see, isn't it? But you can see how you can reduce it from 2/8 to the 4th. Okay, then everything else is in the 4th power. So then I can multiply that and have the 4th root of 48, right? Because I just multiplied those two. 4th root of 48. I can divide them now because they're both 4th roots. I can divide them. This is a hard one.
See how you cancel out this, like how you got to.
Here?
Yeah.
Okay, great. Let me finish this up and I'll come back to it, okay? 4th root of 16. Oh, let me think. Hold on. Because 3 goes into 48 16 times. 2 times 2 times 2 times 2 is 16. So the 4th root of 16 is a 2, okay? Let me stop the recording, Autumn, and I'm going to show you, okay? You'll get it because you're a smart girl.